Here in this thermal neutrons, to slow down these thermal neutrons, moderators are used, and the moderators such as deuterium oxide, that is heavy water, and next water and heavy water are used as moderators to slow down the neutrons, and these control rods controls the number of neutrons generated in the reaction. Here the multiplication factor is reducing by this control rods by the cadmium and boron rods. Now again in this we are using the fuel as enriched uranium and uranium. These we will use as the fuel for this nuclear reactors. This is the fuel, and here we are using the coolant. Here by this most amount of the energy is released, and this energy is cooled down by using the coolants. Here the coolants are molten sodium and water are used as the coolant, and by using this coolant the water is heated, and in this steam exchanger or this steam generator, it produces the steam, it gives the steam, and when this steam is passed on to the turbines to rotate, we can produce the electricity also. This is the nuclear reactor, and this nuclear reactor is also having the shield. Here it is having the shield to reduce the radiations emitted, or to reduce the radiations emitted by this nuclear reactor, and these radiations are very hazardous for the people who are working near this nuclear reactor. This affects more, that's why to reduce that radiations, here this total nuclear reactor is covered with the steel or concrete to reduce the effect by this nuclear radiations. This is the nuclear reactor, and this nuclear reactor works on the principle of controlled chain reaction. In this mainly fuel, moderators, control rods, coolant, and shielding are used. Here in this moderators, these moderators slows down the neutrons. Here these thermal neutrons, it slows down, then these thermal neutrons are participating in the this nuclear reaction, and control rods, this control rods controls the number of neutrons releasing in the reaction, and the fuel is enriched uranium or uranium we will use for the fuel for this nuclear reactor. In this core, the fuel is placed in the core element, and the coolant, this coolant are the molten sodium and water as used as the coolant, and this coolant reduces the energy, and shield, this total nuclear reactor is shielded by the steel or concrete, because this emits the very hazardous radiations. This affects the people working around this. Now fusion process. Here fusion process means this fusion process. In this fusion process, the smaller nuclei are combining to give the bigger nuclei and also releases the energy. The smaller nuclei combining to give the smaller nuclei combining to give the larger nuclei, and also more amount of energy is released. This is called fusion reactions. Generally these fusion reactions takes place in the stars or also in the sun, and here the proton-proton interaction, based on this proton-proton interaction, this fusion process is taking place, and this fusion process takes place at the more amount of, that means at a larger temperatures in the range of 10 power 8 Kelvin. In the range of 10 power 8 Kelvin, the fusion reactions can take place. For example, this proton is combining to H12 and this again H12 and H11 will give helium this 2,3, and this helium 2,3 plus this helium 2,3 will give the helium 2,4, and this helium 2,4 and some amount of energy is released, and this helium 2,4 plus 2 electrons, this 2 electrons will give the helium 2,4 plus again 2 protons, and energy will get 26.7 mega electron volts. Here these are the fusion reactions. Here this proton is combining to get H12, and again here also will get some energy. H12 plus H11 again gives the helium 2,3, and the helium 2,3 plus helium 2,3 will give helium 2,4 plus some energy. Here these three reactions taking place again. Here to get this helium 2,3, these two reactions takes place again. That means these reactions combining to give helium 2,4. Here 4 protons, this 4H11 are combining to give helium 2,4 nuclei. This smaller nuclei combining to give a bigger nuclei plus more amount of energy, 26.7 mega electron volts. If we compare this fusion and fission reactions, the binding energy per nucleon is more in this fusion process. In this fusion process, more amount of energy is released.